Welcome back. Hope you had a good break. We just talked about policies. Now, what goes in a distributed firewall policy? Well, rules. That's what goes into a policy. And I can create my rules simply by hitting the little ellipses button and selecting add a rule. And I can add one or more rules, and I can reorder rules in there. If I need to, I can just drag and drop the rules in the UI here. But I can add rules and start populating those out so that I can start controlling my traffic. And a whole bunch of different fields here that we want to think about. We want to name the rule and define a source and a destination, and define the service and the context profile. That's going to be my layer 7 profile. Define where the rule will be applied in the applied to field, and finally, what's the action of the rule going to be, right? So everything up to the action simply defines how we're going to match traffic, right? What characteristics of a packet are we going to use to match it? And once we match it, what are we going to do with it? That's the action. Now, the source and destination fields, these are typically going to be group objects, and I'm going to go and create my groups separately in NSX. So I'm not going to create them here necessarily. But they don't have to be groups, right? They could be IP addresses or subnets. We have that option if you want to go that route. But we're always going to prefer that you and recommend that you specify and build groups to use for your firewall rules. It's just going to make things way more readable. So how do we create a group? Well, we need to go to the inventory tab, and in the inventory tab, we find groups, and under groups, we add a group, right? It feels like I'm saying group an awful lot here. So that's all there is to it. I give the group a name. I go in and set the membership for that group. And in setting the membership for that group, I can choose whether this is going to be dynamic or statically created. Now, there's nothing in the UI here that says, oh, this is dynamic and that's static. What we're looking at, the dynamic membership option is highlighted in green in the slide here, where we choose our membership criteria and we start to define, if a virtual machine name contains this string, or virtual machine has that tag, or virtual machine is, has an operating system name of Linux or Windows or whatever it might be, right? These dynamic criteria that we can set up, sets of to include virtual machines into this group. Now, on the blue highlight, we can go in and statically define members, and we can go in and select individual virtual machines or select segments, so all virtual machines attached to that segment, or things of that nature. We can statically identify membership in this group as well. We can also build groups based on IP sets. That's really useful for sets of workloads that are maybe outside of NSX that we don't have that inventory information on, so we can't identify those as individual virtual machines. So there are a number of different ways that we can create NSX groups to be used in our source and destinations. Now, tagging, using metadata to identify workloads and manage workloads is really, really, really valuable because it gives us a lot of flexibility, a lot more flexibility than maybe some naming conventions or things like that. I can simply apply this tag to a virtual machine, and that can become membership criteria, whether it's, this is a web server, or this is a PCI compliant workload, or this is in production or development, or whatever we might be looking at. So I build my groups. I use those groups for my source and destination. I can also go in and build my services if something out of the box doesn't support what I need. A service, like I mentioned earlier, is simply an abstraction of a protocol and one or more ports. And that service allows me to just make the rule more readable. Now, we have 400 and some odd services out of the box. I think the last I looked, it was 409, but I think that was an NSXT 3.2. So we're at NSX 4. We've probably not removed. So 400 and some services, which is great. We can cover most of our common use cases. If that isn't enough, if we don't have a service that covers the port and protocol of your maybe custom application or something else that you have going on, you can create your own service objects, which is really, really great. I like having that flexibility to create a separate object there. Now, context profiles give us a whole bunch of flexibility in looking at things above and beyond port and protocol and source and destination IP address. I can look at application IDs. I can look at FQDNs, right? We can do all kinds of things to further filter traffic, further filter the match. And as I go and look, we can define, app IDs or FQDNs for our different context matches. And we've got quite a number of both built in. I can also use my own custom FQDNs for filtering for things that maybe we didn't think about, right? Things maybe in your own domain or things that, FQDNs that just we didn't plug in that you want to filter access to or from. Now, then we have to figure out what the applied to field is going to be set. And the applied to field, sets the scope of rule enforcement, as the slide title says. In other words, it defines for us where this rule will be programmed, what distributed firewall filters will get this rule. Now, typically, when I set this, and I want to set this on most of my rules, when I have to contain the scope of a rule, I'm probably going to set the applied to field to match the groups in the source and the destination field, kind of like we're seeing here. That way, rules that apply to some subset of virtual machines in my environment are only programmed into those specific virtual machines. That's the value here, right? Because I only want the rules applicable to a specific workload programmed into that workload. I don't want superfluous rules programmed in if I can avoid it. And so that's what we're looking at here, right? Set the applied to field. Most of our rules are going to be set to the source and destination, although some rules, such as perhaps the shared services rules in our infrastructure category, may be set to the default DFW, which means those rules are going to get programmed into every distributed firewall filter in NSX, because that's what makes sense, right? Shared services is a great example of that, right? Where I need access to DNS. Well, everything probably needs access to DNS. Let's not limit that rule program. And then we have our action, right? Allow, drop, and reject. What are we doing here? Allow simply forwards the packet. Drop silently drops the packet. Reject will send an ICMP unreachable or a TCP reset, something like that, and actively notify the source that the connection has been denied. Now, we can have settings on individual rules, right? What is the, or not what is, but do I want to log packet matches for this rule? Do I want to plug in a log label? What's going on? Do I want to more easily match the rule? Do I want to mess with the directionality, the protocol? What settings on the rule do I need to mess with? In a lot of cases, we can leave these as the default. Maybe we'll enable logging, but the default in and out direction, right? That's in and out of the destination. And the default protocol IPv4 and IPv6 gives us a lot more flexibility just in case we move from our IPv4 or IPv6 only networks, or just in case we apply these rules to networks that maybe have mixed protocols. Now, something new in NSX4 is being able to block malicious IP addresses. So we have this new capability. We're bringing in a feed of data for these malicious IPs, and that's going to change over time as owners of IP addresses clean up different reasons that they maybe have been caught on that malicious IP list. But this gives me a dynamic way to block traffic to and from known malicious sources and destinations. Now, I have to turn this on, right? This is not turned on out of the box. I have to go into my distributed firewall settings and enable this. And this will help NSX Manager reach out to our cloud services to bring in that feed of data, right? The malicious IP feed of data, and then allow us to start using these malicious IP feeds. Now, we do create a malicious IP feed group straight out of the box. It's just a default. These are all of the malicious IP addresses based on the information that we're curating and then bringing into NSX. And we can turn around and use these this group and this base feed to create our own custom group. So we can define exceptions to that malicious IP list simply by creating an additional group using that malicious IP list. Now, we have rules automatically created in the infrastructure category to block everything coming from one of these malicious IP addresses or going to one of these malicious IP addresses. In brownfield environments, in other words, in upgraded environments where things already exist, these rules are disabled. Right? You can enable them. It's you see the toggle right here on the screen. We just flip those switches to on and they're enabled. But we can enable these if they are not otherwise already enabled. And then I can use the custom IP malicious IP groups that we talked about to create our own rules to block our custom groups of IP addresses, right? This is just another NSX group. Even though it's a special type of group, we work with it just as though it's any other group in our infrastructure that we can use as source or destination. Now, above and beyond all that, I have to operate this firewall. I'm going to, for example, automatically have a draft saved of my firewall configuration when there is a new publish operation. I can view those drafts on a timeline to see what all's been going on. I can also manually save a configuration, maybe for more work later. Maybe I'm building a set of policy and I can't get done with it now. I can save it and come back to it later. I can see those in the same view drafts timeline. And these are both under the actions menu of the distributed firewall, just like where we went to find our settings. As I'm viewing a saved configuration, right, I can select a saved configuration and load that up and see what the differences are going to be between the firewall policies I have in place now and the new policies. So what policies or rules will be created or modified or deleted if I completely load the new configuration. And, I can then load that and work with it. I can also import and export firewall configurations. This is great for maybe bootstrapping a second NSX domain with some set of firewall policy. So I can go in and export and that'll allow me to save a zip file of my firewall configuration. And then I can turn around and import that maybe someplace else. If we look at the architecture of what the distributed firewall is doing, right, how it all comes together and how things work together, we have a whole bunch of individual tooling we can work with. We follow through the NSX Manager the same process that everything else does. So when we publish a firewall rule change, that rule change is going to go through the policy role. Policy will go ahead and program that, hand that off to manager. Manager will make sure we have all of the imperative configuration steps to send off to the central control plane. The central control plane, by way of the appliance proxy hub, will send to the local control plane, or NSX proxy, on the transport node. On an ESXi host, that means we're going to program VDPI, which is the Deep Packet Inspection Engine, where all of our context profiles will be programmed, as well as vSIP, the VMware Internetworking Service Insertion Protocol kernel module that manages all of the distributed firewall filters for all of the individual virtual machines. That's where my firewall rules are going to be built or programmed. Now, we're going to send statistics from those rule hits, right? For our hit counters, we're going to send statistics to a stats exporter process, which will in turn send those statistics back to NSX Manager for us to view in the UI. Now, when we think about rule processing, we have because we're a stateful firewall, we have a flow table or a connection table. The connection table is the first thing we're going to look at. And the connection table simply gives me a list of the already allowed flows. So we want to match something in that already allowed flows list so that we don't have to process all of our rules. But if we miss, right, in other words, if we don't have an allowed flow, it's a brand new flow, we're going to go ahead and once we process the connection table flows and process through those, we'll go ahead and move over to the rules list. First match wins, right? When we find a match, we're going to stop rule processing. And at that point, we're going to update the connection table if we match an allow rule. If we match a drop or a reject rule, right, if that's my action, then we're not going to do anything with the connection table. We're simply going to drop or reject the packet and move on to the next. So let's talk about lab. We're going to come in here and we're going to play with the distributed firewall. We're going to test connectivity. We're going to set up some tags and build some groups out. And then we're going to build some rules and we're going to test and see how this all kind of plays together, right? When we get into preparing for the next lab, we're going to turn off that firewall policy that we created, right? So this is kind of a fun lab, right? Getting to see how the firewall works. Come back in a little bit. We'll go ahead and wrap this video up. All right. We have played with the firewall. We have seen what it can do. And we're wrapping up not just this video, but also the last. We talked about distributed firewall and gateway firewall and the fact that we have two different firewalls. We talked about our policies and how we can organize things in policy and in our firewall categories. We talked about all of the firewall rules and all the components that make those up, right? Groups for our sources and destinations, services for our ports and protocols, context profiles we kind of touched on. We talked about firewall operations by saving and loading firewall configurations. We talked about importing and exporting. We talked about our architecture. All right, lots and lots of stuff. Now, when we come back in the next video, we're going to talk about a new use case for the distributed firewall and how we can use that without perhaps looking at the logical networking and switching and routing of NSX. So a little bit of a different use case. We'll talk about it soon. See you there.